Introduction to Simple Curve Sketching, exercise 6.4 on page 252 of your textbook. There's two main concepts in this exercise, one of which we've already done. The first one is just, can you sketch a graph, right? Which is identifying your maximum, your minimum, your endpoints, turning points, points of inflection, etc., and plot them onto a graph. I'm not going to cover that. We've already done that last lesson, and I'm assuming that you've had a lot of practice doing that as well. But the other concept we're focusing on is tangent and normal graphs. By differentiating, we already know that when we differentiate, it provides the gradient function of a curve. Unless it's a linear equation, the gradient changes over time, which is why we're going to have a gradient function, not just a constant. Knowing this gradient, we can find the equation of the tangent line at any given point. Assuming AB, and it doesn't matter exactly what your format is, but assuming AB is a point at the curve, the equation at the point AB, the tangent of that AB point, is found using this formula, where y minus b equals to the derivative of a, remember, substituting the point of value x, and then multiplying by x minus a, which will give you the same answer. The alternate way we've been doing it is where we've substituted for the value of a to get b, right, and then just found the gradient and substituted into your y equals mx plus c formula. They both work. It's entirely up to you. The only difference between that equation formula of the tangent and the normal, of course, is that the normal has a perpendicular angle or perpendicular gradient. In this case, the normal, of course, is going to be using this formula where we have negative 1 over m or negative 1 over the gradient of our previous tangent. Does it sound familiar so far? Okay, let's get into an example. Find the equation of the tangent and normal, to the curve y equals x cubed plus 1/2 x squared at the point x equals to 1. I'm going to prioritize finding AB and f dash of x. So in this case, I'm not going to write f dash of x, I'm going to write dy dx, purely because it says y, not f. So dy dx equals to 3x squared plus x. And then I'm going to prioritize finding the y value at x equals to 1. So I should say at x equals to 1, y equals to, and I'm going to say 1 cubed plus half times 1 squared, which is just going to equal to 1.5 or 3 over 2. Am I going through this too quickly? Okay. So I have the point 1, 3 over 2, and my gradient function up there as well. Now it wants the gradient, now we're specifically looking at tangent first, it wants the gradient at our x value of 1. So I should say at, I'm going to add it in here, at x equals to 1, dy dx equals, again, so substituting gives me an answer of 4. Then I just put into my formulas. Y minus b. So in this case, it's going to be y minus my y value of my coordinate, which is 3 over 2, equals the derivative at x equals a, or in this case, x equals to 4. So x equals 1, which therefore gives us 4. Brackets, x minus the value of a, in this case is 1. There we go. If the question just says to find the equation of tangent, that will suffice. That is a valid equation of a tangent. It does not specify it needs to be in gradient intercept form. But if you would like it to be in gradient intercept form, of course we just transpose it. We get y equals to 4 bracket. You know what? I'm going to expand it. 4x minus 4 plus 3 over 2, which would give us y equals to 4x. And that's negative 4 plus 1.5. which gives us negative 2.5, which I know is negative 5 over 2. Any questions? Okay. Now let's look at our normal function. Of course, we know normal gives us a formula of m1 times m2 equals to negative 1. Hopefully that sounds familiar. Rearranging that, of course, is just going to equal to negative 1 over our gradient. This is a common mistake students make. This is our tangent. Therefore, when I move to my normal, please don't write this down. Therefore, I'm just going to change that. So that's going to be y equals to negative 1 over 4. It's correct? Yeah? x and then minus 5 over 2, we've just changed the gradient to negative 1 over, or negative reciprocal. Why is this incorrect? Why is this wrong? Graphically speaking, if I've got a function, let's say the tangent's like this, and the opposite, or the normal function, looks like this, is my y-intercept going to be the same? No. We have to apply, you can either use the previous formula, or you can just use your y equals mx plus c, and substitute the same point in. I'm going to use this form, again, using the formula is perfectly fine. I'm going to substitute 1, 3 over 2, because it's the same coordinate, right? And there we get 3 over 2 equals to negative 1 over 4 plus c, which would, if I add 1 quarter on both sides, 6, 7, 7 over 4 equals to c. Therefore, it's y equals to negative 1 quarter x plus 7 over 4. Any questions about finding tangents and normals? There's a lot of revision this term. Okay, let's look at the next question. Find the equation of the tangent and normal to the graph y equals to negative sine x at the point x equals to pi over 3. Just double checking that we're all good in terms of using the calculator. Of course, you're going to go to graph and table. You're going to clear whatever function you have. You type in your function here. Negative sine x. And then I'm just going to draw my function. Why does this look awful? What have I done wrong? I can zoom in a bit more, but it still looks horrendous. Yep, degrees, thank you very much. Is that what you're going to say? Thank you. You're on degrees mode. Obviously don't use grad, so you're going to end up using radians. Lovely. And then, of course, how do I get my tangent? You will go analysis, sketch. Of course, tangent and normal are both there. Tangent, you're going to type in a value. Now, of course, when I type in, let's say, something, it will come up with this box of x equals to what? Put in your pi over 3. Okay, and it will give you a value. Now, here's the point that I think most students, up to this point, most students know this. Do we know how to find the equation of the tangent at this point? Rounded, but the equation. If you just press enter one more time, it will spit out the equation of that tangent right there. So you just have to hit enter twice, and it'll give you the equation of tangent. Please note that it'll only give you the equation of tangent in decimal form. If it's a nice function, you end up with, for example, 0.32. Done, happy. However, if you've got pi somewhere involved, you're most likely going to have pi in your answer. Therefore, it's not going to give it to you in exact value. It can only give it to you in decimal form. A lot of students then make the mistake of saying, well, why don't I just go back to main and hit this? Oops. Change this to get rid of the y equals and just hit enter and change it into non-decimal. It's still rounded. It's already been rounded. You can't resuscitate it from the dead, yeah? So you need to either do it in your main using the formula or using a y equals mx plus c, okay? The graphical format or graphical way does not allow for exact values. Same thing applies for normals. Any questions? Okay.